In this session, we will take up delta star transformer connection. The delta star arrangement of a single phase transformer bank is commonly found at the beginning of the transmission line, where you want to step up the voltage from delta to star, as well as at the distribution end, where we need two different voltages, one between the neutral and a line, and another one is line to line voltage. Means this delta star arrangement of a single phase transformer bank is used usually at the beginning of the transmission line. We know that at the distribution end, the inclusion of a neutral wire allows a choice of two different voltages that I told you, that is between the neutral and one line and line to line voltage for the customer use. At the generator end of the transmission line, delta star connection is used to step up the generator voltage to suitable transmission line voltage. We know that is the transmitting the electrical power with a high voltage has got a certain advantage. Because of that, what we are doing is, for transmitting purposes, we are stepping up the voltage where we are using delta star transformer. We know that the transformation ratio is defined as the secondary voltage to the primary voltage. Okay, that is V2P, that is secondary voltage per phase divided by primary voltage per phase. If you are looking into the line to line voltage ratio, in that case, what we are getting here is VLL, that is secondary is, now it is a star connection is a secondary because it's a delta star transformer, that is a line voltage, it is referred to the secondary side, that is VLL star side divided by VLL, means the line to line voltage on the delta side. It is a primary side, secondary side the line voltage, it is the primary side line voltage. Just you have to express this line voltage in the star in terms of its phase value, that is it is a root 3 times V2P. Whereas in the case of the delta connection, we know that line voltage is equal to the phase voltage, therefore it is V1P, that is a primary voltage. Then we are defined V2P by V1P as a K, therefore the transformation ratio, if you are taking to line voltage, it is root 3 times K. Therefore, at the same time, the ratio of the line to line current is, the current ratio is, it is exactly reverse to the voltage ratio, that is the primary current to the secondary current, that is IL delta by IL star, where the delta connection, we know that line current is root 3 times phase current, that is root 3 times I1 into P, divided by the secondary current is the star, where the line current is same as the phase current. Therefore, what we are getting here, once again the transformation ratio for the line to line current is root 3 times K. As in the case of a star delta transformer, we have seen two different connections for the delta connection. Here also we have got two different connections for the delta connection. The first combination what I am taking is, that is A1 B2 B1 C2 C1 A2. That is the star delta connection side. I have got a three transformer, single phase transformer. I am connecting for the primary delta, secondary star. Here I have got a marking of the transformer. This is A2 A1, B2 B1 and C2 C1 refer to the delta side, and A1 A2 small, B2 B1 C2 C1, it is secondary side. In the primary side, you have to connect in the delta, so that what I am connecting here is A1 B2, that is A1 B2, then B1 C2, then C2 C1 A2, C1 A2, C1 A2, that is C1 A2. Just you have to look into here. Just I am connecting A1 B2, B1 C2, C1 A2. This is a delta connection. This is one type of connection. And in the star connection, either end or start point, end or finish point of a one terminal of a secondary is shorted. Here I am shorting A1, B1, C1. That is become a star point. This is ABC of the delta connection. Now I am charting A1, B1 and C1. Then the remaining terminals I have got a secondary ABC. Therefore, what I am getting here is just have to draw the vector diagram for the delta side and the star side. What I am getting is, let us start with, just I will draw here. This is A2, that is from potential rise is from A1 to A2. Therefore, I am drawing first, I am taking the phase as R, that is A1. Then we know that there is a A1 B2. First I am taking it is A1 A2. This is A1 A2 what I shown here first. Then I have got a B2 B1 which is a lagging A1 A2 by 120 degree, but the connection of the B2 with A1, B2 with A1. Therefore, so that this is A2, this is our A1. Therefore, B2 has to be joined to A1. Therefore, what I am drawing here is it is a B1 B2. It is a B1 B2 which is touching A1 here. Similarly, we have got B1 C2. Here it is a B2 means this is a B1. This is C2 should be here. Therefore, I am drawing it as C2 here. Then we are getting C1 here, C1 A2. We are getting the same connection here. A1 B2, B1 C2, C1 A2. Here you can see here it is a C1 A2. Here it is A1 B2. Here it is B1 C2. So that if you are drawing the shift of the neutral by 30 degree here and refer to the second side that is in phase with phase A, B, C you have to draw for star connection. Here it is a parallel to this A1, A2. We have got a A1, A2 here. Then parallel to this B1, B2 I have got a secondary with a transformation ratio, that is a B1, B2. And parallel to this C1, C2 I have got a C1, C2 with the magnitude multiplied by the transformation ratio. That is what I am getting here. But in this case in the delta connection also we are getting a shift of neutral of 30 degree. Then other combination I am getting, that is A1 C2, B1 A2, C1 B2 base. What I have to do is I have to replace this C1 that is transformer C in place of B. In place of C I have to replace the B here. So that I am getting here if I am replacing it is C2 C1, then it is A1 C2, that is A1 C2. Like that you will get there is a replacement, that is interchanging of the transformer B and C here. In that case you are getting a connection of A1 C2, B1 A2 and C1 B2. In this case if you are drawing a vector diagram, it looks like this. That is A1 A2 as it is. Then here it is C1 C2. It is C1 C2. You can see here. It is A1 A2. Then here A1 C2. A1 C2. That is A1 C2. Then you have got a C1. That is C1 is connected to B2. Therefore B2 should be here. Once again here there is a shift of the neutral of a 30 degree here. Here it is a lag. Here it is a lead. As in the case of the star connection, once again the phases are changed, that is C to B, B to C. That is quite evident here. Previously here it is A, B, C. You can see here it is A here as it is, but here it is B. Once again here B, B and C. That is A, B, C. That is once again we are getting. But there is a shift of the neutral is the lagging in the nature in the case of the A1 C2, B1 A2, C1 B2. Some of the salient features of the delta star the connections are, this scheme of connection is generally used where it is necessary to step up the voltage, for example at the beginning of the high voltage transmission system. On the high voltage side of the transformer, insulation is stressed only 57.7% of the the line voltage. That is quite evident because it is delta star connection. Another advantage of that neutral point is stable and will not float when the load is unbalanced. That is, it is capable of handling unloading unbalanced load also. There is no distortion of the flux because of the delta connection, because the third harmonic contained they are circulating inside the delta, therefore a path for the third harmonic currents because of the delta connection. Therefore it can operate on in the unbalanced condition also, and it is capable of blocking the third harmonic the component. These are some of the advantage of the delta star connection. The next session we will see the delta delta connection.